The Rise of Crispr.
So we was talking about
Test tube uses stimulation embryo, variability of the allele.
Oh, hey guys, are you guys ready for the exam?
I hope so, but we got this.
Yeah, at least we're allowed to use a cheat sheet, so I'm not that stressed.
Wait, what? Wait, we are allowed to cheat sheet?
Bruh, you didn't know we were allowed to have a page of notes?
Oh my god, no way! How come I didn't know? But can you guys help me make one right now, please?
Yeah, no problem.
Let's quickly review and connect it all together.
Okay, so the exam is on CRISPR and how it came about. You know that, right?
Oh yeah, I do.
Okay, good. Okay, let's start with the history of how CRISPR came about.
Okay, so it all began when people were curious about different varieties of plants and fruits.
George Snow, who was a plant scientist, did modern plant breeding and created pure breeds of corn. He selected corn types he liked and bred it with other desirable lines and crossed it to make hybrids. He didn't know what genes he was selecting or what they did, but his corn breeding was successful.
Over time, scientists were able to come up with plant mutagenesis, which gave rise to many different fruits and vegetables.
It took many years for researchers and scientists to discover the genes that actually wanted to look and change. After a century of snow, scientists evolved their ways to make gene alteration more convenient for them.
Hermann Muller was an American biologist, and he was a Nobel Prize winner in the year 1946 on his work on mutation. Muller's main focus was eugenesis, which meant the social direction of human evolution. During his time, he made an important discovery. He said that every new offspring may gain a mutation, most of them not being harmful at the time. However, as time goes on, the mutation will add up, causing it to become a disease. This will cause low fertility rate. Muller's main concern was that the mutation will become too large over time. Due to advantages like medicine, our natural selection has become weak compared to back then. He had a solution for this problem. It's called germinal choice. Originally, children can only inherit genes through sexual reproduction. However, he thought about doing sexless reproduction, the art of artificial insemination, which was successful in a bull. The same thing was tried in humans. Donated sperms were used to help couples when the husband was infertile. It was a taboo in the beginning. However, 50,000 children were conceived in the United States using this method in the year 1960. Sperm donors need to be healthy in order to donate. Later on, this procedure became a success also in women, with keeping a viable egg in dish, thanks to Robert Edwards and Patrick Steptoe. This made vital fertilization possible. To minimize diseases, they will only keep the healthy eggs. Vital fertilization can be used to prevent disorders such as
Wait. This is me. Let me do this. A lady at age 22 found out that she was carrying a faulty copy of HTT gene, and she and her husband used vital fertilization to prevent the next generation of her family from inheriting it. Scientists came up with something called gene therapy, where you alter genes to treat diseases such as beta thalassemia is a hereditary disorder that disables HBB gene, leaving body cells unable to build hemoglobin. This condition causes death because patients' blood cannot deliver enough oxygen around their body. So the scientists extracted bone marrow cells from a boy suffering from beta thalassemia. They infected the cells with the virus carrying HBB and then injected those cells back into his bone. Boy's cells started to make normal hemoglobin, and then he stopped needing a monthly transfusion of blood to stay alive. Then they realized this method could also be used to produce healthy babies, and to test, they had a healthy woman donate eggs, and oplasm of those eggs were injected into the defective eggs and then fertilized with the sperm. They saw the woman was able to produce a healthy baby. Just like that, embryonic cells could help treat lots of diseases as well. Scientists can just pluck a single cell from an embryo made in fertility clinic and use it to make a colony of embryonic cells. So, after a heart attack, doctors could repair a patient's damaged cardiac muscles with new cells. Since embryonic cells also have the ability to become muscles, neurons, or other type of tissues, people suffering with Parkinson's disease could get a transplant of healthy neurons.
Along with embryonic alteration, people are going a step further in the process of genetic preference. The process of vitro gametogenesis triggers what is called the test tube baby business because manipulation of the embryo in many ways raises the variability of different alleles. Using different combination of genes, scientists can create a wide range of different embryonic possibilities. Among these possibilities, couples may even be able to pick and choose certain embryos that may contain genes for lighter eye color or those who even have genes for a greater intelligence quotient. Through alteration of induced pluripotent stem cells, manipulation has become easier. Inspecting the embryo's DNA also helped choose out the embryos that were the healthiest and even some of which may contain a disorder. Questions like reducing the risk of deafness or dwarfism arises with the knowledge and use of gene alteration. It is becoming dangerous because this notion disrupts the natural biological processes. Not only this, but designing new babies becomes unethical.
CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats. It chops off the tip of its incoming DNA and inserts it into a stretch of its own DNA. It was known to many, but its enhancements was a collaborative discovery by Jennifer Doudna and Emmanuel Charpentier. With the use of jellyfish DNA, it was concluded that they had essentially rewrote the sequencing code of jellyfish, causing multiple fragments to appear. CRISPR ultimately solves the natural biological incorrections of faulty mutations to benefit lives on a larger scale, which is an advantage in itself. One con of CRISPR, however, would pertain to its affordability. Due to the advancements of medicine, CRISPR would serve as a means for people of wealth to have over those that cannot afford treatment. It becomes problematic as people will resort to buying their way from diseases and prolonging their lives, leaving others to eventually die off. There is also an issue surrounding consent regarding embryos and the future generations to inherit changes influenced by CRISPR. They don't necessarily have a say as to what gets passed on, or the future ramifications of their actions of their parents and grandparents regarding their genes. No man should ever be given total discretion to determine his brother's fate. The same held true for his great-grandchild.
So, did you get all that?
Wait, so I was supposed to write that down?
Wow. Just wow.
Exam time!